Good morning. So we're going to start today on we're going to continue on document 4.5. So we're going to start. Sorry. I don't know where everybody is though. Looks like a lot of people missing. So have you had a chance to attempt this problem? Would you like me to review it or just send you the answers? Would you like me to review it or just send the answers? All right. Let's see. There's not many people here. It says three. It's only 3 of us. So, well, here's some more people coming now. All right. Okay, so let's see. Your company has been considering introducing a 4-year-long computer hardware system on to its ongoing operations. You can acquire a network computer system which would cost $100,000 and require ongoing maintenance costs of $30,000. So what are those? What is $100,000? What do we call that? How do we refer to the $100,000? Okay, maintenance cost is expense. What do we call this? This is the initial cost. This is the capital spending that we're going to treat differently. This is capital. Spending. And this one here is an expense, operating expense. And both are incremental, right? It is expected that the computer hardware components could be sold for $20,000 in 4 years. What do we call that? All right, so we'll call this one is salvage, and I've just highlighted in green some other important data points. Okay, and then here, what's all this? We refer to this as net working capital. But once we combine in all the figures, this is working capital. These are amounts that need to be, well, they represent allocation of funds for the purposes of inventory, cash, etc. So these are required at the end of each period. And in the 4th year, we recover or return all or release all the funds back to the firm. All right, so then you're told about revenues below. Let's continue. Revenues accruing directly from this project are anticipated to be $30,000 per year. So that's incremental revenue. Other companies will be expected to increase business with your firm with additional anticipated net revenue of $5,000 per year indefinitely. What's that? What should we call that? Okay, so we'll call it a side effect. It's positive side effect. It's a side effect. And where will we put it? Is it... It will also be incremental revenue. It'll be additional incremental revenue, but it'll be incremental revenue. Based on a quantitative analysis of cash flows, determine whether the system should be purchased if the required rate of returns for the project is of this type is 10%. So this is our interest rate, right, that we're going to use. And this is the tax rate. So this isn't so bad. We're going to begin with income. So what goes into income? Income will consist of incremental expense, incremental revenue, and the side effect. Right. So let's begin there. I already sent you the solutions for this, so you already have this. So we begin, we want the present value of income, right? And that's going to be the $30,000 per year incremental revenue minus the $30,000 per year expense. And that would be, I mean, that's zero, but let's just write out the expression. That would be after tax, and it's an annuity. So we use the annuity formula. For 4 years. So that doesn't add anything, does it? What does is the side effect. Now I could actually put it in here. Why don't I just put it all together? Because it's also in, well, I did argue that I wanted to see everything separate. Okay, so let's just put it separate. So this is revenue minus expenses. After tax. And we've covered it for the whole duration of the project. And then we're going to add the side effect. Now you could put them all together, wouldn't be wrong. Also after tax, because you have to pay taxes on that revenue. And that turns out to be $30,000. Second, I'll put this in red. Second, let's look at investment. Let's go back and identify what is part of investment. We have to include the capital spending, the effect of the salvage, net working capital, and what else? Oh, this is wrong here. I did this wrong. This is indefinitely. I just remembered. I have to fix that. It's not an annuity. It's forever. So this is not 30,000. It's forever. So it's like that. Sorry. Well, that's quite the assumption, right? We're assuming forever. We're assuming that we'll always use this required rate of return and that the tax rate will be the same. But we'll just do that for an estimate. And that's 30,000. Now, back to investment. So we have the initial investment of $100,000, $20,000 salvage, and networking capital. So let's do this table, and then we'll do the depreciation table, and then we'll put it together. Okay. So for this table, I'm going to expand it. The first step is to sum these up. And when you do that, you get okay, so those are the amounts. Now I want to figure out what more I need. So from immediate moment to the end of next year, I need an additional amount set aside for this project. So I begin with calling this net working capital required. And then I compute the net working capital changes. Incremental, right? I need the incremental. So that is 2,300. For the next year, I just need an extra 400 from here to here. Then I don't need so much, so I'll release some of the funds. And finally, release all the funds back to the firm. And lastly, I'm going to turn this into net working capital, investment, cash flows. I got to turn these into cash flows for investment. So that would be, from the perspective of the firm, 8,900 in the first year, or immediately, 2,300 by the end of the first year, 400, and then the released amounts. Okay, now these cash flows I need for my table, or for my calculation. And then, let's see, we have that. So let's do the depreciation table now. So for $100,000 at 40%, no, sorry, we have $100,000 and we need the 7-year schedule. So let's go to Excel. I already have this one. And this was for 7 years, so let's just use it. I'm going to change, actually all I need to do, I'm going to change this to 100,000. And then maybe make the columns, oops, bigger. And then here, I'm going to change this to 100,000. Oh, I don't put the comma in. And then I have to copy that all the way down. How does that look? This has to change, then that'll be fine. There you go. So that's my table. Any questions? So I just followed along the same, it was the same tax rate of 40%. It was the same depreciation schedule of 7 years. And my book value is then 31,200. So I can take this with me back to the case. Here we go. All right, so we have those two tables done, and now we put it together. The present value of the initial investment is $100,000. The present value of the net working capital investment is the immediate amount of 8,900 plus negative so these are the investment cash flows. and you put that together with your calculator and your CF keys. So I just took those ones that I calculate from here and I put them in this table, in this calculation. So then I can put that into my calculator. I can go to CF and second clear work. And I put 8900 negative, enter down, and then 2300 negative, enter down, down, 400 negative, enter down, down, 2000, enter down, down, and 9600, enter down, down. And then you say NPV with an interest rate of 10, enter down, and compute. And that's the value. And I just take 2 decimal places. What I can do is store that, so I maintain all the decimal places for the next part. So now that's in store 1. So this amount is 3,261.93, and I can store that in 1. With all the decimal places. Now the tax shield. Oh, I'll call it after tax shield, because we're going to take care of the tax issue. So this is the present value, which is actually the present value the salvage plus the tax rate on the difference of the book value and the salvage value, because I get tax savings if I sold it for less than it was worth, and that's why this is a plus. But I have to pay taxes if I sold it for more than it was worth. So that would be a negative. In this case, we sold it for less than it's worth because it was only 20,000, but the book value is 31,000. So just make a note that the market value this is an estimate. We don't know for sure, but that's what we estimate for the purpose of this analysis. So that's the value. I'm going to calculate that in the calculator and store that in 2. Presumably there will be decimal places, so I'll put ... So clear my screen and I start in the brackets 31,200 minus 20 times equals times 0.4 plus 20,000 equals divided by brackets 1.1 to the power 4. So that's how I got that. And now I'm going to store 2. So we have recall 1. Oh, that's a negative. Yes, it's supposed to be a negative because it's an investment. And recall 2, that's a positive because of tax savings. Oh, and the sale. We didn't save taxes. We actually, wait, what happened here? Yeah, we did save. So 16,000 rather than 20 because of the present value of future cash flows and time value of money. Okay, so what's next? No questions so far? Put them together. So I'm going to put them together. G. So just to go back a moment, so the present value of income was 30,000. And the present value, I'll move this up a bit. And then the present value of investment is equal to summing those together. It's very messy, isn't it? Let me do that again. So present value of an investment, of the investment, is equal to, when you sum those together, you get a negative. Investment is a negative because it's an investment, it's a cash outflow, so that will be negative. That's okay, and I can round that now. Now I can store that in 1. I'm going to override what I have, or no, I'll store in the next, what do I have so far? I have 1 and 2, so that I can store this in 3. And the last part, the easy part, we're going to collect from the depreciation, all the tax shields as a result of depreciation. So let's put all those together for the tax shield, and then we add everything together. So that's these amounts here. So we have to make an expression So again, you can use the NPV. Don't forget the first one is 0, right? Because there's no tax shield in a time now. It begins at the end of the first year. So when you put those together, you get 21,973.44. And some decimals, I imagine. And you can put those in store 3. Store 4. Well, what I'm going to say to you is you can round these. Like each section, you can round them. I mean, I'll put it in store 4 so I don't have to retype it, but you can round off, you know, each part 1, 2, and 3. That's fine with me. I think it should work to get you the right answers when you're solving problems on my documents. So let's do that. Let's do that together with the calculator. So I've stored, what's my store 3? Okay, so store 3 and store 4 I need. Okay, I want to get this for store 4. Let's put those together. Clear my CF work. And then enter 0 and begin with the tax shield 5720, enter down, down. 9800, enter down, down. 7,000, enter down, down, and 5,000. And then ask for NPV, tell 10%, enter down, and compute. And that's what we got, right? And I said, let's put that in store 4, did I? So what we have to do now is add recall 3, recall 4, and the first one. $30,000. See, but I have all these decimals. Oh well. Let's do recall 3 plus recall 4 plus 30,000. Wait. Clear. Recall 3 plus recall 4 equals plus 30,000. So 6313.18. What did I do wrong? Oh, the investment is negative. Okay, do that again. So recall 3, this is not what I want. I want recall 86. Where did I put 86? Recall 4? No, I think I overwrote it. Let's do it again. Okay, I'm going to put 1 and 2 together and make something's weird. How do I get 86,000? Oh yeah, because of the initial cost. Okay. Because this one is negative. That's a negative. and I put them together and I get that. So let's do that again and store 3. I think I skipped some steps. So I'm going to put together initial investment, recall 1, and recall 2 and store it as 3. Recall 1. That's the working capital plus recall 2 minus the 100,000 is store 3. So that's the investment. And then I'm going to add that to recall 4, which is from the tax shields, and I'm going to add the 30,000 from income. And that's my answer. So that's how I get that result. So to recap, this is for the tax shields. This up here was for the investment. And I got that because this one is a negative, and these two parts. This was net working capital investment, which was a negative. It's a negative. And then, and the first one was 30,000. So it's a little long. Any questions? So your final answer so I get the exact decimals if I don't round anything. And this means because it's negative, don't invest. Any questions? Which parts? Any parts confusing? It's just that it's long. I think you have to stay organized. Remember what you've done. Okay, so I'm going to try, since you have the answer to part 5, question 5, I am going to go on to another document. I'll go to document 4.7 to continue. Because we still have 4.7 and 4.9. Is that all right? Okay, so let's move to 4.7. It's a long one. So what I'm going to do is I'll give you 5 minutes to do something. Read it, and then I'll go through it with you. So take 5 minutes to read it by yourself. I'm back. How'd you do? You still there? Oh, how's it going? Okay, let's look at this together. Can you guys tell me if anything is confusing, or do you understand it? Are there any terms that you don't understand? Or where it goes? No? All right. Jorge, owner of Trillo Pan American Technology, so TTT, is pursuing a special project related to the use of cable television technology for internet access. TTT has already invested $1 million into research and development connected with the design and production of a new black box for use in conjunction with existing television sets, and is now considered a leader in the field. The project advantages are expected to last 4 years. Okay, so I need that information. But this one I don't need, right? Because this is already spent, invested. This is R&D, so that's not included. To put this project to full-scale production, it will have to invest $3 million in production equipment, but expects to be able to sell it to a competitor after the 4 years for $500,000. So this is capital spending, and this is salvage here. So because it's capital spending, we don't put taxes on it. It's not seen as an expense, and we use tax savings in the initial year, but we expense it over time. And that's why we separate it from the income piece, which includes revenues and expenses. So this is the salvage here. 5-year schedule. New machinery could be depreciated on a 5-year schedule, rounding to 2 decimal places. Okay, so it fits the 5-year schedule. Oh, sorry, I'm going to put that in green. Have a color system here. According to the maker's table, I'm rounding to 2 decimal places. Let's see what happened there. Rounding to 2 decimal places. Let me make sure that that's how it is in the solutions. I didn't use 5 years, I used 7 years. Okay, so 5-year schedule. Let's go to makers and look at the 5-year schedule. I had a feeling something was up. You know, it makes it much easier if I just change that. Oh, no, I opened the wrong document. Hold on. 4.7. 2 decimal places. Yeah, okay. It's like that. So makers, if I go to makers, 5-year schedule, that's not it. This one. And let's take them now. And so for this asset class, it's considered under 5-year depreciation. So I'll put it here. not what I want to do. Okay. Alternatively, they could lease the equipment for $50,000 per month. Okay, so this is an alternative. So there are two things we have to look at. It's either that or the alternative. With a lease, rather than buying it, they lease it. And notice it's beginning of the month payment. They would also have to pay $100,000 safety deposit. So you'll just see that as an expense immediately. The safety deposit would be reimbursed when the equipment is returned. Okay, so this is the alternative. This would be as an expense. And this one would be as also an incremental expense. The safety deposit would be reimbursed when the equipment is returned undamaged. So that will be at year 4. Make a note that that's at year 4. Or 5. How many years is this? 4 years. So make a note here at 4 years, at year 4. One advantage of leasing equipment is that the lease payments would be tax deductible. Aha. Right? So anyway, it's tax deductible expense. So we'll treat it like the regular expenses. All right. So it expects to receive pre-tax revenue of, okay, so now that those two investment options vary, but the rest is the same, I think. Let's see. For both. They expect to receive pre-tax revenue of $2 million per year for each of the 4 years of the project. Also estimated that additional expenses for each of the 4 years will be incurred. So for both projects, these are the same. If it proceeds with the project, working capital requirements related to project will be increased. The projected net working capital requirements are as follows. So this has already been, these are the requirements. They've been combined for you. They also estimate that undertaking the project will result in increased labor cost. Okay, so let me highlight some of these things. This is revenue. This is revenue. This is expense. And this is net working capital spending. No, net working capital requirements. All right. Okay, added expense. I'm sneezing. One moment. Okay, I'm back. Increase in labor costs of $550,000 indefinitely. Assume all cash flows occur at the end of each year. So the rate of return is 15% and the tax rate is 40%. Should they lease or buy the equipment? So since this portion here is identical whether they buy or lease, I actually don't have to do this part. This is not going to be different between either of them. All right? Provided this is a positive, I guess you need to check that this is not a negative, right? Let me think. Well, we only have to calculate it once, at the very least. Do you understand what I'm saying? And in the lease case, we have to assume that there's no damage to the equipment. We'll have to assume that. Once we see the numbers, we can talk about it, whether it looks tight, that we can't do this, we can't afford for the equipment to be damaged. So let's look at this and make sure that this looks like a positive. So it's $2 million in revenues, $500,000 in expenses, and then these amounts each year, and then increased labor costs of $150,000 indefinitely. I guess it's worth checking that all of this is a positive first. And then we can look at these two situations separately. Actually, you know what I'm going to do is leave this. Assume I'm going to say assume the net no, and let's not assume it. Let's just check it later. Let's do the controversial part and then we'll check this, or I'll leave it for you to check. So verify that these amounts have a total positive NPV. Okay, so do that for tomorrow. And I'm going to focus on the other part. So first, let's look at the option of purchasing the equipment. So we're going to answer part I here. Okay, so evaluate the impact of the NPV of the project if the equipment is purchased and resold. Include the effect of the purchase price, tax shields, and salvage value of the equipment. So this is what we're going to work on. No, I'm not going to be able to do that nicely. All right, so I'm just going to go to the next page. I'm going to call it the present value of the purchase option. Or I'll stick with what I wrote in the notes. It's fine. Present value fixed asset purchase. Is negative $3 million. And the discount rate, the required rate of return is 15%. So let's make the table. For $3 million asset. I don't know how to make a lowercase d with my me and my iPad. And the tax rate is 40%. Okay, so this is the same. But I have to change this one to 3 million. And the rate is for the 5-year depreciation. I only take 4 years because that's the duration of the project. And then I multiply each of these by 3 million. And I can calculate depreciation, the tax shields as a result of depreciation by multiplying these again by 40%. So those are the tax savings, $240,000. Due to depreciation, and then a bit more, 40,000 the second year, and so on. And then figuring out what the book value is, I begin with 3 million and I subtract off the depreciated amount in the first year. So that's, if I did this right, did I do too many zeros? Yeah. So that's 2.4 million. Now I want to take this amount and subtract all the way down. So just note that the first one is from 3 million and the rest is from what remains. So the book value is 510,000. Questions? Now, we can get the tax shields from there and the salvage. That's it. That's all we have to do. The salvage was 500,000, so it's pretty close, but we do end up selling it for less than the book value, so there's going to be tax savings. So let's put together the present value of the tax shields I put a 0 in there just to remind you that this starts at year 1. I should actually write 1, 2, 3, 4 to remind you. Did I say 24,000? It's 240,000. 1.15, then 384,000 for 2 periods of discounting, and then 228,000 for 3 periods, and 144,000 for 4 periods. And when you discount all that, you should get $731,300.99. And you can store those together in one. And the book value was $510,000. And the market value, or the salvage, was equal to $500,000. So we have to account for the fact that we can claim that loss. So we're going to get $500,000, but because of the IRS, the book value can be claimed less the salvage value as a loss. So we incur tax savings, and this is going to be $288,163 when you discount it. 64. Oh, sorry. Let me put it in there. This all happens at year 4. So you discount all of that. That's not what I wanted to do. You discount that and you get $504,000 discounted for 1.5 to the 4. So 288,163.64, and hold all those decimals, store 2. And really that's it. Need to put that together with the fixed asset purchase of $3 million. And you have the net present value of buying. It's $3 million. That's the purchase. Plus the tax shields. Look at that, almost $1 million, $750,000 in savings from the tax shields. And 288 from the sale of the asset. So this works out to ignoring or not computing the income, you see that the buy option is almost $2 million cost. So your income, the one that I left you to do, has to exceed that, right, to pursue the project. But we still have to compare it to the other one, the other alternative. Any questions so far? So buying will cost negative $2 million. We have to make sure that it's worth buying. Let's do the other alternative. The other alternative is to lease. If it's less, then we'll be more inclined to the lease. And that is what's going to happen. So we begin with the evaluation of the lease option. Regarding the safety deposit. Now the safety deposit is going to be $100,000 initially, but that's a tax deductible expense. Then we're going to assume that the equipment is not damaged and we get our $100,000 back. Now because it's later, it's 4 years from now, it's not worth as much, but we'll account for that by discounting it. So this is after tax, so we compute that. And it works out to be negative $25,694.81, and you can store that with the decimals in 1. And there's only one other thing. We have to pay for the lease. The lease, let's go back and look at the case. Look what it says. $500,000 per month paid at the beginning of every month. So how do we do that? How do we compute that? You want to try that? Try that part and put in the chat your result. How's it going? So this is an annuity due. So you have to write this down. As 50,000 plus 50,000 and you can put the monthly rate as an annuity for 47 months. Yeah, because it's 48 months. Remember the annuity due formula. So 12 times 4 is 48, but this has to be one less up here because there's 48. And then once you get that, you need to multiply it by 1 minus TC. And that's the present value of the lease. So we need to get the monthly rate from the 15%. And it's a exponent thing, remember this. We have the effective annual rate, and we need the effective monthly rate, and $12 of these is equal to 1 of these, because these are smaller. So 12 of these months makes a year, and that creates that. So that'll give me my monthly rate, and I should store that number. I already stored 1, so store this in 2. So this works out to be 0.0117149. Oh, why'd I do it in red? So you need to multiply that by 10 to put into your calculator. And so it's 1.15 to the power of 15 going to flip it, equals -1. That's a different answer. Wait a second. 1.15 to the power of, what did I write here? 12. I put 15. 1.15 to the power of 12 inverted equals -1. That is my rate. And I said I would store that in 2. Now, I want to use the annuity due, so I'm going to say begin mode, second begin, second set. So now I'm in begin mode, and tell the calculator that for 48 months, so I just entered as though it's a regular annuity, and the calculator does the adjustment. I want to recall my rate and multiply by 100 to put it in the interest, and then it's 50,000 every payment. Put 0 in future value and ask for the present value. Now that's the present value. So I don't know if I'm going to store that, or I'm just going to multiply that by 0.6. So this is the amount of the lease. That's the present value of the lease. So I'm going to store that in 3. The present value of the lease, when all is said and done, is 1,109,517.80. So I'm going to store that in 3. And I keep it as a negative because it's an expense, or it's a cost. So when you put together NPV of the lease is equal to the present value of the safety deposit plus the present value of the lease. And that's going to be recall 1 plus recall 3 for a total of -1,109,000. Sorry, that's not right. I recopied the other one. It's going to be -1 million anyway. $135,212.61. Which is a smaller negative than it is to buy. So it looks like the lease option is better, but you still have to check that income exceeds this so that the overall NPV is positive. Okay? Any questions? So it's just long. It's just a lot of exercises in one. And I will give you a case on Saturday to work with. You have to lay it all out. Questions? Very good, Kevin. So I'll send you this clave so you guys can have it. But the last part would be to make sure that all this information on the revenues, less the investment of the net working capital, and the expenses, including the labor costs, makes it worth it. You still have to check all of this to make sure it is more than the lease option. All right. So I think that's all I want to say about capital budgeting. You have to practice. You have still one more to try, and I'll send you the clave for that one. Let's read it. Let me open it up and have a look at it to see if you have any questions before I leave you with it, or if it just looks like the others. Okay, any questions? So this is also like you have to compare two options. All right, so if you have no questions, I'll leave you with those and I'll send you the solutions and you'll have to let me know if you have any questions. Okay? It's just long. Otherwise, you have all the tools to do this. You just have to pace yourself and get through. Okay, so with that, unless you have any questions, I wanted to start the statistics review. Okay? Give me a moment. I'm going to send you the review problems. The review notes. Okay, so I sent you those documents. And that's what we're going to work on today and tomorrow. Now, this is going to be an investment in time because it's going to make things flow much smoother next week if we know how to use statistics to help us. So, here we are. Everybody receive the documents? Okay, so why do we study statistics? What is the point of statistics? I'll ask you the first question. What is a statistic? Give me a definition of a statistic and an example. So I'm speaking in general terms, and then I'm going to spend next week focusing on finance, obviously. Okay, I only see a few people watching right now. So that means that the students will have to watch this video later or use their knowledge of statistics if they don't. But we're going to fly through it next week, so it's really important that you do this review. So what is a statistic? A statistic is, or an example would be average GPA of students in their fourth year. An example could be the median income of households in San Juan metro area. A statistic is a number calculated from data in a sample. That's what a statistic is. That's the most general explanation I have. With what purpose? Why do we do this? The idea is that the statistic A statistic is a number computed from data in a sample. The idea is that I can, in a cost-effective way, I guess, gather a sample and learn or gain information about that characteristic that I'm measuring. So if I'm measuring student performance, something like a GPA would be an indicator of student performance. Very good, Daviana. So a statistic is a number computed from data in a sample. And what is its intention? That's the whole thing. What is the intention of the statistic? Why do we do this? Well, because we believe there's a population of data out there that our sample aims to represent. And that population has characteristics. So if it's students, it has certain characteristics, and we want to know their abilities or their performance. We want to capture that, but population usually is difficult to acquire. Like all of the data, all of the information available is difficult to acquire. Now, something like an institution like the UPR, you could probably get all the information on student, so that you could do that and actually calculate the GPA of all students. But it all depends on the ability of the record keeping and the collection of all that information. It does cost money to keep, house, and update all that information routinely. So when we think about this, we want to think more general about populations we cannot get all the information on. So something like learning about all individuals' income in the metro area of San Juan, that might be difficult because people might not be documented, people might be homeless, people might not be traceable for whatever reason. Or they don't respond to calls or communication. So it's hard to get it's hard to get all the data on the population. So instead, the second best thing to do is to collect a sample. From that sample, we can calculate statistics based on the data in the sample, and the statistic aims to estimate the parameters of the population. A parameter is a number computed from data in a population. Now, whether a statistic is a good estimate of a parameter depends on a number of things, and one of those is how good the sample is, how representative it is of the population. Okay? So to remember this terminology, parameter starts with a P and population starts with a P, and statistic starts with an S, and sample starts with an S. I'm saying this because people use the term parameter quite loosely, and it's very specific in statistics. It's referring to the possibly unknown characteristic of a variable. Okay, and so that's what the word statistic is used. The statistic is meant to estimate the parameter. So the parameter is really our goal. How many of you knew that? I think muestra, you say muestra in Spanish, but other words, otherwise, I think you still say población. Parameter is probably something like parameter, and a statistic is estadística. So there's a variety of different kinds of statistics, and the ones that are really important to us are the sample mean, the sample mean, it means to estimate mu, the population mean. Mu is a parameter. S, the sample standard deviation, aims to estimate the true or population standard deviation. Okay, and some other statistics I'll discuss, although in finance, at least in this course, we focus on the mean and standard deviation, so those are mostly it. But you know about also the alternative to the mean is the median, or I'll call it the sample median. This is also known as the 50th percentile, and we'll talk about percentiles. It's the middle observation if you order data. So the sample median should estimate the population median. So I don't know. There's not a really standard. So these symbols I've printed here are standards, universal standards. Sample mean is x bar, population mean is mu. This is the Greek letter M for mean. And S is the sample standard deviation symbol, where sigma is the Greek letter S, lowercase s, for population standard deviation. And there's no real standard for the median. We just use M, and it's an estimate. I don't know. I don't really want to write this, but you know, I don't know. That's just another example. I'm not going to put a symbol then. That's what I'll do. I'll avoid it by just no symbols. So the sample median is another example, and the population median would be what it's trying to estimate. Okay, so those are examples. And one more that's popular and that you've learned about is proportion. Proportion is really important. Proportion of people who wear masks in public places, a proportion of people who vote Democrat, something like that. So proportion, sample proportion is one you learn about. And it estimates the population proportion. And these symbols are also rather standard. So I put a hat on the sample one and to indicate it's different from the true one. Okay? So, having said all of that, these in the sample are meant to estimate these in the population. So what is the goal of statistics? The goal of statistics is to gain information from data about a variable so that we can better understand what to expect. And I'm going to add in as a goal to alleviate uncertainty. Statistics is instrumental in dealing with people's anxiety, giving them some answers. People want answers. And statistics do that. They give you some sense of what's going to happen in relative proportion. You know, this is more likely to happen in that than that, etc. Okay, so it allows for decision making. So any characteristic of a person or thing that can be expressed as a number is called a variable. So dollar sales, quantity demanded, interest rates, those are all variables. The value of a variable is the actual number that describes the person or the thing. When we have data, we like to display the data first in a graphical representation, and that graph reveals what values the variable takes and how often it takes those values. And this is for a sample, or even if we have all the population data, we would do something like this. So we need to first graphically represent the data, and then based on the graphical representation, we decide what statistics to use. And I'll give you an example. And here are my definitions that I just described. Okay, so I've said all of this here already. All right, so where I'm going to start is an example. Here's my example. This is the data that has been ranked and arranged demonstrating how much shoppers spend in a store. So you can answer the question how much shoppers spend in a store by summarizing what is seen in this graph. This is known as a stem and leaf or a split stem and leaf graph. This is the first digit and this is the second digit. And I put all the data here. And I've rounded, just assume this is all the data, and they've been rounded to integer values. The second question we want to answer is, how can the data help improve the store's marketing strategy? So when we look at this data, are you okay with what I've put here? So the data here has been put with a stem and a leaf. And the reason why there are two digits is because the data in order is $2, $7, $7, $8, etc. all the way to 69. Now because the last one in the ordered data set, it has two digits, they all need to have two digits. So I put a 0 in front of the single digit numbers. So what we do now that we have displayed the data is we need to summarize it. And we begin summarizing by smoothing out this curve here. Now I could say that I think that if I had more data, I believe that there will still appear three groups of shoppers. This is a group of shoppers that spend a low amount, or a low amount of money. There's the middle group that spends a middle amount of money or medium amount of money, and then there's the high spenders here. The more they spend, the less shoppers there are that spend that much. You could think that, or you could think that I think that if there was more data, I believe it would just be like this, that this gap would fill in, and there would just be one group of people here, and then this group that spends a lot. So depending on what, maybe once you do the analysis and think about it a little bit, you can decide if it's the gray curve or the yellow curve. What I'm talking about, these are density curves. Density curves is an idealized version of the distribution. As if you had all the data, what you expect to see. Okay, now you could be wrong, but based on what you have to date, you have to make a statement. And what I'm going to do is I'm going to stick with this version because I have a story to tell about the gray option. Let me do it again. So I'm going to fix this and just pick the gray one with the three groups in it. Now I've divided the data in equal intervals of 5 . Okay, I like the three groups. So these are equal intervals, and this one includes the values from 0, 0 to 0 to 0, 4. So there's 5 possible numbers in there. And the next one starts 0, 5 to 0, 9, and then 10 to 14. So this way, each of the classes, that's what these are the classes, are mutually exclusive. So when I look at this data, I want to make some statements, some summary. And the way I do that is I use the 5 features. The 5 features include first, shape. The shape of this distribution is asymmetrical. It's not symmetric. A symmetric distribution is what we're going to focus on soon, but this is known as a right skewed distribution. It's characterized as, I'm going to turn this on its side. So we usually look at them like this, right? As a number line on this axis, going from small numbers to large numbers. And a right skewed distribution has just a few observations in the extreme, but most of the observations below. And when a distribution is right skewed, it influences, or skewed in general, it influences our measure of center and spread. The statistics we use to measure the expected value, or the center, will differ than if the distribution was symmetric. what is the expected value for skewed data? Which value would you depend on, or which value would you predict would be the spending of the next shopper walking into the grocery store? What single number would you think would be the amount spent by the next shopper? What number would you compute to capture that? Well, it turns out that whereas most of the time people will say just calculate the average as the expected value, that doesn't work for data that are skewed. Right, Daniel says propose the mean, but that doesn't work for data that are skewed. That's described here in the notes. So what is the mean? The mean, you can remember this drawing, or you can remember this sentiment. The mean is the value closest to all the other data, closest to all the other points. In that sense, it's the center of gravity. The mean is the value closest to all the other points. Now, it might not be the one of the values or one of the observations, but it's in the middle and it's closest to all of them. So it sits so that it balances the density on one side from the density on the other. You see? So it's closest in that sense. It balances the distribution. So the problem with that, I mean, that's great, it's the center of gravity, but in terms of, so that relates one value to all the other values. But in terms of making a guess, if you pick the mean, that is, notice it's moved away from most of the clump of data here, and it's pulled towards just a few values over here. And that's problematic because there's only a few over here, and there's way more over here. So it's more likely that the observation, the next person coming in, will be in this group than way over here. So how do we adjust for that? We have a different measure for that, and that's called the median. So the median is useful because the median doesn't include all the values. The median is computed as the middle value of the ordered data set or the average of 2 in the middle. Since this data has 50 observations is an even number, there will be 2 observations in the middle. And I'm not going to get into that so much because I'm not going to teach about the median much, but you need to know the difference. Okay, you need to know the difference. So for expected value, we don't use the mean, we use the median. Let me say something more about this as well. So here we have the different shapes, right? So which shape, we're this one, we're right skewed. And in the right skewed distribution, it's different than the symmetric one. The symmetric one is in the middle here. For the symmetric distribution, the balancing point is here, right, on A. So the mean is in the class at A. It's in that group. It's one of those numbers in there. So you got to remember, I haven't put the data in here, but you could, okay? So the mean is there. Also, here is the mode, the modal class. It's the most frequent observations occur. The most frequent class is this middle one. So this middle is mirrored on the right and on the left. And it says that most of the values are at A. Some are higher, but just as many are just a bit lower. And some are much higher, but just as many are that much lower. So it balances out on either sides. And what you expect if you were to bet is that observations would occur around here, very, very close to the middle. And your best guess would be the mean. It turns out that also in the middle is the middle observation, of course. So if you were to put all the numbers in order, you could find the one in the middle, and that would be the median. So it turns out in symmetric data, the mean, median, and mode are all basically the same. Having said that, the convention in statistics and economics and finance is when data are symmetric, we just use the mean. Okay? We only use the mean. Statistical software will report the mode and the median, and you can still calculate them, but in analysis and discussion, in computations, the mean gets used primarily. That leaves the mode as an important descriptive value, because it tells you can see it on any graph, and a graph is always what you do first. In any graph, you see it right away. It's where the peak is, or any of the peaks, because you could have more peaks. You could have more peaks than one. So you see the mode. So it's important that we can see the mode and to talk about it. But you should also now, since you've taken statistics, most of you, and now you're doing this class, you should also be able to see the mean and the median. The mean will be the measure that's closer to the tail. It will be pulled towards the tail because every single value goes into calculating the mean, and that pulls the mean towards it, away from the greater majority of the data. So the mean is closer to the tail. If it's a right skewed distribution, the mean will be closer to it. If it's a left skewed, the mean will still be closer to the tail on the left. And in the middle, you will always find the compromise, the median. The median will be in the middle. Or if it's an even amount of observations, it'll be the average of the two in the middle. It's the middle observation. So some examples, for symmetric distribution, many physical phenomena are symmetric, like height and weight. scores on standardized tests. Those are all symmetric. Right skewed distributions are income. So if you ever hear about income, household income measures, they will be right skewed, because there's the 1% people talk about, the few very rich people that skew the distribution to the right. So when reporting on income, the median should be reported, not the mean. You need to check first, though. You need to check your distribution and then pick median rather than mean. For left skewed distribution, this is where most of the observations are high, just a few low ones. That could be possible too. I use the example of school grade completed. Most people have at least a grade 9 or 10. Many have more than that. And in terms of school grade, kindergarten to grade 12, there's very few people with no education. But they skew our distribution. So that's about the mean measures. There's other measures that we're going to talk about in the coming unit. And another measure in finance that we use is the geometric mean. The geometric mean is calculated by a multiple of values. So you multiply them, and because you multiply them, then you have to take the nth root to find the average of that multiplication. So it's done like this. Now you've seen this before, but you've seen it more like this, right? You've seen that we can put rates together, factors of accumulation, and calculate the average among those minus 1. So we're going to talk about this when we have different rates over time. If you wanted to know the return on an investment after 1 year with one rate, but then the rate changes, then this would be after 2 years with a different rate, up to T different years with T different rates. This would be the accumulation over that period, the holding period of that investment. And you could calculate the average by multiplying those and taking the Tth root. So we're going to talk about this. This is a geometric average return. And what's really important about this is that this kind of way of measuring the average it's resistant to outliers. It's resistant to extreme values. It's like a median in that way. And I'll show you, we'll see an example of that next week. All right, so I've kept you guys quite late. I will pick up this review tomorrow, and you have all the notes. Hopefully I can do it in an hour and a half, because tomorrow I need to go somewhere at 10:30. So we're only going to have class till 10:30 tomorrow, all right? And then if you have any questions, you're going to have to contact me in preparation for the test. But I will email you all the solutions. We're going to finish with the review over the next day or so. And next week, I really want to start into risk and return and looking at, since now we figured out how to make a projection of cash flows, the next step is to figure out how to compute an appropriate risk-adjusted rate of return. So you guys have a good day. See you tomorrow, and then good luck on your test preparation. Okay? Take care.